This is section 2 of chapter 11, and in this section we will discuss main effects and interactions. All right, so factorial designs allow researchers to examine how unique combinations of factors influence behaviors. And by factors, I mean independent variables. And here we will focus on the simplest possible factorial design involving only two factors and two levels of each factor. So a 2 by 2 design. So in such a design, there are three sets of information, or put it differently, there are three questions that you can ask. Question 1 is, what is the overall impact or influence of factor 1, of independent variable 1? Question 2, what is the overall influence of factor 2? And question 3, do these factors interact with one another? So questions 1 and 2 refer to what are called main effects, and question 3 refers to what are called interactions. All right, so let's consider this study here, and I'll explain it. So in the study, people were given study material and were later tested on that material. So that was the dependent measure. How well are you able to learn this material that you are given? And there were two independent variables. One was the mode of presentation for the material. This had two levels. So the material was either presented on paper or on a computer screen. And the second independent variable was control of study time. So people were either given a fixed amount of time to study the material, or the study time was not fixed, but rather self-regulated. And so this creates a classic 2 by 2 design. And we will consider this study as an example when discussing main effects and interactions. All right, so let's begin by discussing main effects. Now, a main effect is the mean difference among the levels of one factor. So for example, you might focus on presentation mode and ask, on average, did the mode of presentation make a difference? Did it matter whether people studied the material on paper or on a screen? And so what you are doing is temporarily treating this like a one-factor study by focusing only on one of the factors while sort of ignoring the other for the time being. And if you find that there is, on average, a difference between these modes of presentation, paper versus screen, then you would say that there is a main effect of presentation mode. And then you could do the same thing for the other factor in the study. So in a two-factor design, there are potentially two main effects that you can discover. So here we have a hypothetical data set for that study that we discussed. And if we were to ask, is there a main effect of presentation mode? Then what we want to do is average across the other factor, study time. And what you're left with would be two means. The overall mean when the presentation mode was paper, and the overall mean when the presentation mode was a computer screen. And then you want to see, is there a difference between these means? And here it appears that there is a difference. On average, people did worse when the presentation mode was a screen as opposed to when it was paper. And this difference implies the presence of a main effect for presentation mode. Now, in the real world, you wouldn't just ask, is there a difference? You would use a statistical analysis to see if the difference is significant. And if it is, you would conclude that there is a main effect of presentation mode. And now you can imagine doing the same exact thing, but for the other factor. So is there a main effect of study time? And now you will average across the presentation mode. So you will average within each row, and for each row you will get an overall mean, and you will compare those means to see if there's a difference. And in this case, looking at these values, it appears that on average, people did better when study time was fixed compared to when study time was self-regulated. And again, in the real world, you would apply a statistical analysis to see if the differences are significant. And if they are, you would conclude that there is a significant main effect of this other factor, control of study time. Okay, so we talked about main effects. Now let's talk about interactions. So factorial designs allow researchers to examine how combinations of factors jointly influence behavior. Now, sometimes the effects of one factor are independent of the other factor, and these are called independent factors. And other times, one factor influences the effect of the other, producing what is called an interaction. One common example that you may have encountered is with drugs. So if you get a prescription for some drug, your physician or psychiatrist will check the other medications that you may be on, because we know that one drug can interact and modify the effects of another drug. This is called drug interactions. So the idea is drug A and B together may produce a different effect than either drug by itself. So maybe drug A can increase the effectiveness of B, or maybe drug A can block the effects of B. So those are examples of drug interactions. And factors in a psychology study can also interact in similar ways. One factor can modify the influence of the other. That's called an interaction. All right, so here we have the hypothetical results of that same study, but now the values have been altered to include an interaction. So suppose we ask, does presentation mode, paper or screen, make a difference? But now, instead of averaging across study time, we will examine this question for each level of the study time factor. So fixed time or self-regulated time. So does presentation mode make a difference for the fixed time condition? Well, for paper, we have a mean of 20. And for computer screen, we have a mean of 20 as well. Those numbers look the same to me. There's no difference. So if you were conducting a single factor design using only fixed time, you would conclude that presentation mode of the material makes no difference. People do the same whether you use paper or a computer screen. But now let's consider the self-regulated time condition. Does presentation mode matter for this condition? Well, for paper, the mean is 20. But for computer screen, the mean drops to 12. And let's just call that difference significant. So does the presentation mode matter? The answer is it depends on the level of the other independent variable. For fixed time, no, it doesn't matter. For self-regulated time, yes, it does matter. So this is an example of an interaction. So there are different ways of defining and conceptualizing the idea of an interaction. And your book gives several definitions, I believe, but I prefer this definition here, where an interaction occurs when the effects of one factor depend on the level of the other factor. So that's an interaction. And if the factors are independent, such that the effect of one does not depend on the level of the other, then you have no interaction. So one way of visualizing an interaction is to plot your data, your 2x2 design in this case, using line graphs. So here we have this graph where on the y-axis you have the dependent measure, in this case the mean exam scores. On the x-axis you have one of your factors, one of your independent variables, in this case mode of presentation and the two levels. And here for each level you're going to plot the values for the other two levels of the other factor, right? So for paper, you will plot the fixed time value of 20 and the self-regulated time of 20. So those two dots are going to overlap there. And then for screen, you will plot the fixed time value of 20 and the self-regulated time of 12. And now this creates this line graph, which allows you to visualize your data, and also it tells you whether or not there's an interaction. And here's how you know. If the lines are parallel, then there is no interaction. However, if the lines are not parallel, as is the case here, that would be evidence of an interaction. Here's an example of the previous version of that experiment, this time without an interaction. So we're playing with two hypothetical data sets here for teaching purposes of the same experiment. But anyway, if you plot it the same way, okay, to make this line graph, what you'll notice is that now the lines are parallel, and parallel lines indicate that there is no interaction between your factors. And you can sort of see it just by looking at the values in the matrix. So if we ask, does presentation mode matter? The answer appears to be yes. People do worse when using screens than paper, and the difference is about 4 points. And this is true both for the fixed time and the self-regulated time condition. And if we ask, does control of study time matter? The answer, again, appears to be yes. People score higher in the fixed time condition compared to the self-regulated time condition. And the difference is 4 points. And this is true whether the information is presented on paper or on a computer screen. So the effect of presentation mode does not depend on control of study time. There's a 4-point difference for each study time condition. And similarly, the effects of controlling study time does not depend on the mode of presentation. There's a 4-point difference whether you use paper or a screen. Therefore, there is no interaction between these factors. They are independent of one another. So another way to spot the presence of an interaction using the data in your design matrix is to compare the mean differences in any row with the mean differences in any other row, or the same goes for columns. So for example, if we look at this row here of fixed time for paper and screen, you have values of 20 and 20. The difference is 0. Whereas here you have 20 and 12, and the difference here is 8. Now, because there is a difference between the mean differences of each row, this would imply the presence of an interaction. Now, you still have to use the proper analysis to see if the interaction is significant, but this is an indication of an interaction. So, when interpreting main effects and interactions, you have to be a little bit cautious. So let's consider this study plotted here, and here's the data matrix. This is a 2x2 design where what is being measured is high school performance, high school grades. And here we're looking at kids that watched a small amount of television versus a large amount of television. That's one factor, the amount of television. And the other factor is the type of television they watched, either educational or non-educational. And so we have 4 conditions, and we are measuring the high school grade average in each of these conditions. Now, what you notice here is that there is a main effect of television type, programming type. So kids who watched educational programming did better than those who watched non-educational programming. Okay, there's a main effect of that factor. But for the other factor, television amount of viewing time, there does not appear to be a main effect. There are means of 77 for both levels, small and large amount of that independent variable. So it looks on the surface as if the amount of television doesn't really matter. But looking at the line graphs, we see that the lines are not parallel, indicating the presence of an interaction. And so if we look closely at these numbers, we see a more interesting and more nuanced story. So for example, for the educational condition, a large amount of television, of educational television, resulted in higher grades than a small amount of educational television. However, for the non-educational condition, it's the opposite trend. So here, a small amount of non-educational television resulted in better grades than a large amount of non-educational television. So yes, the amount matters, but the amount interacts with the type of television that is being watched. But because the main effect averages across both of these levels, these patterns get lost in that average, and it looks as if the amount of television doesn't matter, when in fact it does, but it interacts differently with the type of television that is being consumed. So a two-factor design allows researchers to evaluate 3 sets of differences. One is the mean differences from the main effect of factor A, then the mean differences of the main effect of factor B, the second factor, and finally, the mean differences from the interaction of these 2 factors. So let's look at an example. Here we have a 2x2 design with a matrix and a plot. And here we have an example of a main effect of factor A. How do we know? Because if we average across factor B, you end up with a mean of 20, overall mean of 20, and overall mean of 10. So this is a main effect, assuming these differences are significant. However, there is no main effect of B because the overall means are the same for the two levels of B. And there's no interaction because, as you can see here, the lines are parallel, which means there is no interaction. All right, here we have an example of a situation where there's a main effect of both factor A and factor B. So if we take factor A, if we average across the two levels of factor B, you wind up with an overall mean of 20 and 30. Assuming this difference is significant, that would be a main effect of factor A. Now, factor B, if you average across the two levels of factor A, you wind up with an overall mean of 15 and 35. Assuming this difference is significant, that would be a main effect of factor B. So you have a main effect of both factors. But looking at the line plot, these lines do not intersect. They are parallel, which indicates the absence of an interaction, meaning these two factors are independent of one another. And finally, you have a situation where there is no main effect of factor A and no main effect of factor B. And you can see that by looking at the means, and the means are the same for both factors. However, looking at the line graph, we see a clear interaction. The lines intersect with one another. And looking at the values in the matrix, we can see that interaction. So you can see that scores from factor B increase by 10 points from 10 to 20, but only at the first level of factor A. At the second level of factor A, they decrease by 10 points from 20 to 10. And so when you average across this, you end up with the same overall column means. And the same thing goes in the other direction. So that's a classic interaction. Here, the effects of B depend on the level of factor A, and the effects of factor A depend on the level of factor B.